Hey everyone, in this section, let's look at the concept of repeated games. A repeated game does not end in a single period but recurs year after year and decade after decade. The optimal strategy is to cooperate and restrain from competing as hard as possible because if you compete in period 1, your rival will reciprocate in period 2. So here we have two side-by-side pair of matrices for two stage games. We have two players, Too Cool and Thirst-Q. We have a situation in which Too Cool is introducing a new cola called Cool Cola and has two advertising options, a high promotion budget and a normal budget. Too Cool's opponent Thirst-Q has the same two options, a high promotion budget and a normal budget. Now, the Nash equilibrium in stage 1 is cell A, which is 10 and 10 for both Too Cool and Thirst-Q. So if we want to look at the Nash equilibrium profits, stage 1, we have Too Cool and Thirst-Q. It's gonna be, I'm just gonna say $10 million for each of them. However, the Nash equilibrium solution is not efficient because if we move from cell A to cell B, both firms can do better. Too Cool can do even better if it can move from cell D to cell B. It could achieve this $16 million of profit in cell B, provided that Thirst-Q is following its normal budget, and Thirst-Q is going to voluntarily do that. If you look at stage 1, Too Cool chooses the promotional budget and it has a profit of $16 million. Thirst-Q chooses the normal budget and it has a profit of $8 million. So the question is, why would Thirst-Q sacrifice $2 million in profit? As if Thirst-Q chose like the Nash equilibrium strategy, if the solution was cell A, the profit would have been $10 million for both the firms. It's because Thirst-Q knows that Too Cool would reciprocate in stage 2. So in stage 2, Too Cool introduces Quench It, that's another new product, and it has again the same actions, promo budget, and is Thirst-Q that introduces Quench It, and we still have the same actions for both the players. So if you look at stage 2 here, whatever Thirst-Q followed in stage 1, Too Cool will follow in stage 2. So it reverses. Stage 1, Too Cool was following promo, Thirst-Q was following normal strategy, and stage 2, Too Cool will follow the normal budget and Thirst-Q will follow a promotional budget. And the profit from this normal and promo is $10 million for Too Cool and $15 million for Thirst-Q. But even in stage 2, the Nash equilibrium strategy is 11 and 11. If both of them followed the Nash equilibrium, the profit would be $11 million for both of them. Now, if you want to calculate the profits from reciprocity, Tukul's total profit from stage 1 and stage 2 is 16 and 10, because stage 1 the solution was promo and normal. Stage 2 the solution reverses, it becomes normal and promo. So this profit is 16 plus 10, 26. And for thirst Q it is 8 plus 15, which is 23. And this is definitely greater than the profit from Nash equilibrium outcome. So the profit from Nash equilibrium outcome is gonna be $21 for each of them, because we could have added 10 and 11 here and 10 and 11 here for both the firms. So without formally colluding and risking antitrust penalties, the firms could increase their profits by reciprocity. All right, hope this makes sense. Thank you very much.